Okay, time to solve problem 3, I believe, the limits one, part B. We have another limit. This one is solved differently. Now, again, if you have some radical plus minus some number, then that's rationalization. But in this case, we don't have radical involved at all, so that's not going to be rationalization. You know, that's the thing about limits, that there are a couple of techniques you could use, and you can't just use one formula in order to solve it. It requires a little bit more effort, and it involves a little bit of judgment as to what you can use, what technique you can use in order to solve it. But there's only so many cases that you need to solve, only about like 3 or 4, plus the formulas that you need to remember. So let's copy this one. X approaches minus 1 of x squared plus 2x plus 1 over 2 times x cubed plus 1, the entire thing squared. Now, what was the first step when solving limits? First step is to directly substitute or like plug in minus 1 for x everywhere, right? That's what the first step was, okay? Always plug in x first. So let's do this. This is gonna be minus 1 squared plus 2 times minus 1 plus 1 over 2 times, now I'm gonna use square brackets, so I have minus 1 cubed plus 1, the entire thing squared, okay? So that would be, if I have minus 1 raised to the power of 2, it's just 1. 2 times minus 1 is minus 2 plus 1 over 2 times, and now minus 1 cubed is just minus 1 plus 1 squared. Now, numerator is 1 plus 1, 2, minus 2, 0. Denominator is obviously also going to be 0 because this is 0. And when we multiply something by 0, it's 0. So, again, we get an indeterminate form, which means that we should go back to the original limit and try to somehow modify it in order to get a better form, where we can actually plug in minus 1 and get a value, not 0 over 0. Okay? Now, let's see what we could do. Firstly, in the numerator, I see something that reminds me of a quadratic equation, right? I have x squared plus something times x plus a number, constant. Okay? That is a quadratic equation, and I could try to factor it out, okay? Now, you could do that through the discriminant formula and everything, but I think it's much easier to do the following. So, you take the constant, and you also take the whole number before the x, along with the sign, okay? And you need the following. You need to find two numbers that, when multiplied, give you this thing. Let's start with that. You need to find two numbers that, when you multiply them, they give you the constant. So that could be 1 times 1 or minus 1 times minus 1. We're only working with whole numbers here, so you don't need to think about anything more fancy. These are the only two options. And then, out of these combinations, you need to find the one that, when you sum the two numbers, they give you the yellow part, okay? So when you multiply them, they should give you this part here, the green one. When you sum them, they should give you the yellow part. Okay, so out of these that we have listed, if we try 1 and 1, 1 plus 1 gives us exactly plus 2. Therefore, these are going to be the values that we're going to plug into the factorized version. So the factorized version is going to be x, and now we plug in the first number, plus 1, times x, and then the second value, which in this case happens to be the same, plus 1. Okay? Or in other words, this is x plus 1 squared. You could write it either way, it doesn't really matter, okay? Alright, that's the sort of simpler part maybe. Now, the denominator is quite interesting because, oops. So, bro, come on. You're joking. Okay. And actually, I forgot to write down the limit. You remember how I told you that unless you're plugging in and you're getting rid of the x, you need to copy the limit part. So let me do so promptly. X approaches minus 1. Okay, So now in the denominator, I could try to expand this, right? Because we have a formula for a plus b squared, but if I start squaring, I'm gonna get x to the 6th plus, what is it, 2x cubed. That has nothing to do with my denominator. So this is not really gonna be the way, right? You could give it a go, but you're gonna hit a dead end, okay? The better thing to do is to recognize the inner formula in here. That's the same as x cubed plus 1 cubed, which is the formula a third plus b third, right? Now, what does that formula say? So in the denominator, I'm gonna copy the 2 in front, and I'm gonna have some expression raised to the 2nd power, but what will that expression be when I expand this formula? Now, I actually don't quite remember this formula. I think it was x plus 1 times x squared minus x plus 1. I'll actually Google it on my computer because I'm not sure. As I told you, I don't really remember formulas either. X squared plus, x cubed plus 1 cubed. X plus 1, x squared minus x. Okay, I got it correct. But yeah, you need to just memorize these for the exam. I'll actually try to just like compile all the formulas and send them to you guys so that you can have them all in one place. But again, I know it's annoying, but you need to remember them, right? So again, this thing, I'm not a genius who can actually, understand how this is expanded. This is just a formula that I should remember, right? Whenever you have something cubed plus something else cubed, you need to remember the formula. Okay, so we have this. And I'll keep going. Give me just a sec. Like this. So I have limit as x approaches minus 1 of x plus 1 times, or actually I'll just write it squared this time, I think it's more convenient, over 2 times. And now, whenever you have two things multiplied and then the entire thing is squared, that's the same as just squaring each of them separately, right? Now, I just want to warn you, if you had a plus here, you could not just separate them and square each of them. But in this case, we have multiplication, so I can just take this one and square. So that would be x plus 1 squared. And then I take the second expression and also square it, okay? So that's going to be x squared minus x plus 1 squared. How does this help me? Well, you can probably see, right? You can see it. We can cancel these out. Like Professor Truly says, these guys out. Let's cancel these guys out. So now we get limit as x approaches minus 1 of 1 over 2 times x squared minus x plus 1, the entire thing squared. And at this point, I will just try to plug in minus 1 for each x and see what happens. Because at the top I have a 1, which is a good sign. If it were 0, it could have been problematic. But now I have 1 at the numerator, so let me just plug in the x and see what happens. So I would have 2 times minus 1 squared minus minus 1 plus 1 squared, which is 1 over 2 times. Now, minus 1 squared is just 1. Minus minus 1 is plus 1. Plus 1 squared. So this gives me 1 over 2 times. 1 plus 1 is 3. I need to square it. So that's 1 over 2 times 3 squared, which is 9. And that gives me the final result, which is 1 over 18. Okay? So that's the solution to this specific problem. I think factoring out the quadratic equation is not that hard. I think remembering this formula is the slightly greater challenge, but again, I'm going to send you a list of formulas and you just need to put in a little bit of effort in order to remember them and practice recognizing them in actual problems. So yeah, I hope this video was helpful and I'll hopefully see you in the next one.